Hello and welcome to another walkthrough. Now this time it will be Edexcel IAL P1 May 2025, which I have never seen before. So this is going to be a blind solve for the entire paper under the real exam conditions. So along the walkthrough, I might be making mistakes, which I'll correct if I realize in the walkthrough. But if I don't, I'll annotate the video and I'll try to explain the worked solution and the thought process as simply as possible. At the end of the walkthrough, I'll mark the paper anyway. For those of you who make mistakes a lot of times, you might benefit from seeing me making a mistake and correct it later. So this walkthrough is not meant to just show you the destination of the solutions, but also show you the journey to the destination. If you feel like jumping to a particular question, you can use chapters in the description. Otherwise, stick around. You might be getting some tips along the way. If you are ready, I'll see you in there. I'm gonna start the timer now. We're going to take the real exam condition here. Okay, number 1. Given that P equals 1 over 16 x to the 4 and Q equals that, express each of the following in terms of K x to the n, where K and n are fully simplified constants. Okay, so P to the half, right? Wait, hang on. In terms of K, power of x to the n, where K and n are fully simplified constant. Yeah, okay, so P to the half is just 1 over 16 x to the 4 to the power of a half. So we power a half in both 1 over 16 and x to the 4. So half to the, we power by a half. It's like square rooting, yeah? So this is 1 over 4, this is x to the 2. And that is it. For B, PQ to the minus 1. So I'm just going to do PQ to minus 1. I'm just going to multiply them first, put them in the same brackets here, and then to the minus 1. So we should, right, simplify them first. So if we simplify them, we get just the x cancel out, so the 4 cancel, the 8, so I think it's just 8 cancel here is 5 over 2x to the power of minus 1, right? Yeah. And that is just what? We need to make it x to the n. So if we put the power minus 1 to 5 over 2, we get 2 over 5. If we put the power minus 1 to x, we get x to the minus 1. Because we need to follow that k x to the n format. Okay? So C, PQ squared. So PQ squared is just P times Q, which is Q squared, which is 40 over x cubed squared like this. And then how about just expand, right? So this is x to the 4 over 16 times 40 times 40 x to the 6, right? Just expanding the square in there. And then we already know that the 40 and the 16 is like 2 and 5 here. And then the 2 also cancel the 40, 20, yeah? So that's just like 100 on top, and at the bottom we have x squared left. But then we should write 100 times x to the minus 2, because that's just to follow the format again. Now let me double check my work, right? Yeah, I think I'm gonna say I'm happy with that. Yeah, with all of that actually. Yeah, I'm fine. Let's do the next one. Number 2. Okay, number 2. The curve C has an equation that find dy by dx, writing your answer in simplest form. Okay. Yeah, this is easy, but you just have to be careful. I mean, you can make silly mistakes all the time. You have to be careful. So dy by dx equals, well, differentiating 2x to the 5 over 2 is just to multiply in front by the power there, and then the power is 1 less. So 1 subtract from 5 over 2, you get 3 over 2, right? That is just the first term. Minus differentiating 4x, we should get minus 4, and 3 goes away. So the 2 cancel the 2 there, we have 5x to the 3 over 2 minus 4. Each term simplest form, yep. Part B. The point P lies on C given that the x coordinate of P is 2 to the k, where k is a constant. The gradient of C at the point P is 16. Find the value of k. Okay, point P lies on C. X coordinate of P is 2 to the k. So if we want the y coordinate of p, we can just plug 2 to the k into the y function above there. And the gradient of c at p is 16. So let's do the gradient first. So the gradient at p, yeah, is just x to the equal 2 to the k there. I'm just substituting x as 2 to the k into the dy by dx. So we should get 2 to the k and powered by 3 over 2. Yeah, basically that. Okay, just keep it at that first. And then the x coordinate of p is 2 to the k. Wait, hang on. Point P lies on C. The x coordinate of p is 2 to the k, where k is a constant. Gradient, okay, the gradient of c at p. Okay, we equate that to 16, right? Yeah, because it says 16. So we solve the equation there. 5 times 2 to the, if I multiply the powers there, is 3 over 2k equals 20. So 3 over 2k equals 4. But 4 is 2 to the 2, isn't it? Right? So now we can say 3 over 2k equals 2. Because if the bases are the same on either side, then you can just equate the power. So k equals 4 over 3. Just that. I mean, we don't need to even care about the y coordinate of p, right? Did we? Okay, so, I mean, I'm quite happy with that. Let me just double check everything. Yep. Yep, okay, let's go to the next part. Where was that? Part B? Okay, yeah. Just checking. Yeah, I'm very careful. Okay, number 3. Although I'm this careful, I still make silly mistakes, guys. You can't be so sure about the silliness of human mind, right? Okay, integrating that. Okay, now, by the looks, we should expand first. When you see something, a complete square or even a cubic, yeah? So that's x squared plus 6x plus 9. When you expand that out, 3, and this is just x to the half, right? Just make it like that. And then instead, if you split them into 3 partial fractions, you're going to get, this one is 1 over 3 x to the 2 minus half is 3 over 2, yeah? Plus 3 dividing into 6, so we get 2 here, and then this is x to the half, plus 3 dividing into 9, we get 3, and this is x to the minus half. All right, all that. Let me double check again. Yeah, I'm happy with that. Okay, so integrating the first term, we leave the 1/3 unchanged. And then x to the power of 3 over 2, we plus 1, so that becomes 5 over 2, and then we divide by that added power. And the other one, the same thing, x to the power of 3 over 2, because I added 1 there, and then divided by the added power. That is also the same. Minus a half plus 1 is just a half, and divided by that half. Yeah, don't forget the plus c. And then I simplify all this. I should have 2 moving up there. So I get 2 over 15 there, x to the 5 over 2, plus 2 moving up here as well. So I get 4 over 3 there, x to the power of 3 over 2, plus 2 moving up as well, 6x to the power of a half, plus c. Well, I'm going to call it at that because I think I'm careful every line I wrote there. So that's simplest form. Number 4. Figure 1 shows a sketch of the part of the curve with equation that, okay, where x is measured in degrees. The points P and Q lie on the curve and are shown in figure 1. Okay. State the coordinates of P. Right, so by the looks, we have 4 cos x here. So the maximum is 4, the minimum is minus 4. The coordinates of P in this case then would be something of a y is 0. But okay, guys, for the normal cosine function, right? For the normal one, the maximum being 1, minimum being minus 1, you need to know this, yeah? This is 2 pi, 3 pi over 2. What is that? Pi, that's pi over 2. Yeah? You need to know this basic. So P here seems to correspond to this point, right? This very intersection, which has the x of 3 pi over 2. So we can actually take that only when there is no transformation in the x. And that's the case, because when you see y equals 4 cos x, there is no x transformation. I mean, the x transformation would have looked like cos 2x maybe, then you would need transformation there. But because there is no transformation of any kind, so we're just going to take the same x coordinate. So that would be the coordinates of P, all right? And the coordinates of Q, let's see. Okay, so Q is also a minimum here. So that's some kind of like -4, because I told you earlier, 4 multiplying there would make it stretching on the y-axis by 4 times. So maximum would be 4, minimum would be -4. Now, how do we do with the x? Well, if we extend the graph to the left side of the x-axis, right, what do we have? Well, guys, it's just the same as this side, right? So that would correspond to the negative pi, wouldn't it? Yeah? It's just the minimum, the first minimum there, right? That's just the negative pi, yeah? So we would have a negative pi and -4 here, right then. So I hope that's fine. So I'm going to keep this graph for you so that you can kind of like see, yeah? Okay, now let's do part C. Part C, state the number of solutions of the equation. Yeah, this is the tricky part, and you got to be careful, because I've seen students struggle in this kind of part for this kind of question, and sometimes they hate this question, okay? Right, real experience here. State the number of solution. All right, so 4 cos x equals 3, right? Because we kind of know that, yeah, it's good that I kept the graph. We kind of know that this is at 4, this is at y equals 4, so if we want to use the graphical kind of representation of the solution to that CI part, we can just draw this line of y equals 3 and see, you know, how that goes. Like how many points do they intersect? Now we got to get some idea first, because they want from 0, yeah, from x equals 0, like from the origin to the right. So the very strategy that I would suggest you guys use is to think about the minimal period first. That is like the repeat unit of cost, right? Because if you go for another period, it's going to look exactly the same. So you know how many points they intersect, then you can repeat that for the next periods. So for the first period, they intersect at 2 points, right? Just for the first periods. But how many periods do we have? Well, right, so we're going to do 2 times. How many periods? Well, one period is 360, but then they want from 0 to that, 18,000. And I hope that is a multiple of 360, right? So I'm just going to try to do 18 here, cancel. 2 down here, so that's 50. Yeah. Is that right? I think it's 50. Let's use a calculator, right, guys? So, no. Divided by, yeah, 50. Okay, so 50 and then times 2, right, is 100. So there's 100 solutions there for this period. Okay, and then part II. Hi guys, just a quick one here. This statistics always blows my mind. So as you can see, for the past 28 days as of today, 90% of those watch hours come from those of you who aren't subscribed to my channel. And that gives me an urge to beg you, please help support me by subscribing the channel. I will return this huge favor by creating more and more videos. I'm going to utilize my teaching experience for 10 plus years to create the videos covering tips and tricks and the hard bits in the topics that most students struggle to understand. It can either be a short video, a long video, but they will sure come up. So that is why you need to subscribe to stay tuned. I hope we have a deal. Let's get back to the walkthrough. 5 plus 4 cos x equals 1. in the interval minus, okay, so they do symmetrical now. They do left part and right part, but you see the extent to the left and right are the same. Minus 720 and plus 720. That means if you can just get some multiple of each side, and 720, you need to know that it's like a multiple of 360 as well. It's 2 periods, 2 times 360. So again, you know that this one is 2, and another one is another 2, and this is already 720. So you have another 2 here as well, and another 2 here, right? Because cos function is symmetrical. Left and right, exactly the same, right? So how many of them? 8, right? So we just do 2 times 2 times 2 here, because 2 on each side and 2 periods on each side. And that is just, oh, hang on. Wait, sorry. I did look at the function. Okay, again. Yeah, I flopped there. Okay, the periods are left and right the same, but the function is not. Okay, let's modify the function a bit. So this is actually the function, the equation to solve. So I just move 5 to the right part, and then I got minus 4 there. Well, actually, it's just this line right here. Kind of similar. Same concept, you see. Each period on either side, they have 2 intersections as well. I would have been right, yeah, if I actually made that silly mistake of not reading that actual equation, but I would have been right. But that was a fluke, so I shouldn't be proud of that. So it's 8 still. Because each period is 2, you have 2 periods on either side, so that's 8, right? Okay, so number 3. Well, yeah, that's kind of similar now. We have 4 cos x equals 4. Why do they're still playing with this? Wait, hang on. Oh, no. Sorry, guys. This is minus 4, not minus 3. Okay. Do you see the mistake there? I just spotted that, okay, that was a flop because I thought it was a minus 3. But actually, yeah, that's why. Okay. It is actually this line, right? Because this is minus 4 down here. My apologies. Well, then, I correct my mistakes. Yeah, that's a minus 4 there. And that line is actually, 4 cos x equals minus 4. So, okay, either side, they intersect 1 point each period, right? So if we have 2 periods, then they intersect 2 points. So it's just 2 times 2 equals 4. 2 points on one side, and then you have another minus 720 there. So that's in total 4 points. So 2 points here and 2 points here, yeah? Okay, the last part. Yeah, 4 cos x equals 4 this time. So 4 is just moving the line to the top bit here, right? Just touching the peaks. So this is y equals 4, right? So what's the solution? We have 10,080. That is just 3 periods, right? 3 periods there. Well, that shouldn't be too hard because we know already that, you got to be careful because I just checked that you must have plus 1 here in the middle. So you do either side and then you plus 1. Yeah, you do both sides and plus 1. So we have what? In one period, there is 1 here and 1 here. If we don't count this, there is 2. Yeah, there is 1 on one side, but there are 3 periods on one side, so 3 times 1, that's on one side, but there are 2 sides. Yeah? And then plus 1, because there's the one in the middle. So this is 6 plus 1, 7. All right? That would be my answer there. I think I'm okay. All right, let's check there. 150. Yeah, I think I'm okay with that. All right, so number 5. The line L1 has equation that the line L2 passes through the origin and is perpendicular to L1. Find an equation L2. Well, this is easy peasy. So, well, you might want to make y the subject. That's probably the kind of like the typical method. So 2y equals x plus 25. I actually just move the 2y to the other side, and then that would give me 1 over 2x plus 25 over 2 for the linear equation. Yeah, let me just put my do not disturb on. Here we go. And then the gradient of line L2 is then the perpendicular one, right? Because it's perpendicular to L1. So that is just minus 2. And then they intersect each other at the origin. Oh, no, sorry. Line L2 passes the origin. Yeah, line L2 passes the origin. So it's just y minus 0 equals minus 2, x minus 0. So that's just y equals minus 2x. There you go. Okay, simply. Let me double check, right? 1 over 2 minus 2, yeah, passes origin, perpendicular to L1. Right, I'm okay with that. And then part B. The line L1 and L2 intersect at point P. Okay, use algebra to find coordinates of P. This should be fine. So we equate the two equations. So what? I'm going to do x plus 25 over 2 equals minus 2x, right? Just equate the two functions there. So x plus 25, moving the 2, so we get minus 4x. So I have 5x equals minus 25 and x equals minus 5, right? Yeah. If x equals minus 5, then y equals 10. Yeah. So that's just coordinates of P is then minus 5 and 10. Yeah, that's it for part B. Part C. Hence find the shortest distance from L1 to the origin. Okay, L1 to the origin. Interesting. L1 is that line. So I'm going to roughly draw L1 and origin here. L1 is x plus 25. So that's like 25 over 2 is like 12.5, right? So something like that. That's y equals 1 over 2x plus 12.5, because 25 over 2 is that. Well, shortest distance, right, from the origin should be that length right there. Yeah? So what do we do? Well, hang on. Look, isn't this line also the y equals minus 2x, right? Because it's the only line perpendicular to this line, and it happens to pass the origin as well. So if we want the shortest distance from L1 to origin, it must be the points on the orange line there, which is y equals minus 2x. So, and the logic is that we already know the intersection between them, which is point P, and it was minus 5, 10, right? Minus 5 and 10. Yeah, that's right. So we just effectively find the distance between these two, which is just to find the distance of P away from origin, which is just to do the Pythagoras of that particular point. So it's just that. Really? Well, let's do that too. Yeah? I mean, using some diagram to help you visualize and some logic, the question would be easy. I mean, I guess if you didn't see it like this, maybe it would have been hard. So that's square root 25 plus 100, and that's square root 125, fully simplified surd, so that would be 5 root 5. Yeah? Just that. Okay, so I'm happy with that, I think. Next one, number 6. Okay, number 6 here. Ooh, what is this? We have the shaded area in figure 2 shows the the plan view of a helicopter landing pad. The area consists of the major sector AOB of a circle center O joined to a triangle AOC. Given that, blah blah blah. So AO equals AB. Sorry, AO equals OB. AO equals OB. Okay, so that's just part of the sector there. BC equals 2, right? Okay, that's yeah, major sector AOB. All right. CBO is a straight line. CBO is a straight line. Okay. Angle ACO is 0.6 radian. Part A. Show that angle COA is that. COA is that. Let's see. Okay. So we know that ACO is 0.6, right? That's 3 marks. COA. Okay, I think we can use sine rule, right? Let's do sine rule, yeah? So we want this angle COA, this angle theta here at the center. But we already know that ACO is 0.6. And we also know that AO is 15. So that's opposite to 0.6. Yeah. Okay. BC is 2 meters. So yeah, so this whole thing is 2 plus 15 equals 17, right? Because BC is 2 meters and OB is 15. So we can kind of calculate this angle right here as well. Yeah? So using sine rule, sine of 0.6 over 15 equals sine of some angle. We're going to find this angle first. Just going to call it alpha, sine alpha over 17. And then we can use pi minus the other two to get that theta there. Okay, so alpha would be equal to 17 over 15 sine of 0.6. And that's in radian, right? I'm going to use a different calculator here. There we go. So, wait. That should be arc sine, right? Yeah. Okay, so in radian already there. No. Arc sine 17 over 15 times sine of 0.6. So that is just 0.694405. All right, just carry up to that. And then we do theta, which is angle COA equals pi minus alpha minus 0.6. So we do keep that as an answer first. So pi minus answer minus 0.6, right? And that gives me 1.8471879 blah blah blah, which is just 1.3 decimal places 847. There you go. Okay, so part B. Find the total area of the helicopter landing pad. It's just everything, right? Yeah. Okay. Total area. Well, we can do sector and triangle separately, yeah? So it's just the sector here. This is a sector, a major sector, right? It says major sector, yeah. Okay, so that's just 1 over 2 theta, which is this major angle. So you gotta be careful. You gotta do 2 pi minus that angle we had earlier, this one. Yeah. Just gonna write that. Dot dot dot. Yeah. 1 over 2 theta r squared. So r is 15 squared. Okay, that. And then we're gonna minus plus the area of the triangle, which we had the diagram here. So which one should we do? I'm just gonna use these two sides and this angle here, yeah? So that's just half AB sine theta. Half times A times B times sine of that thing. The same thing, yeah? 1.847 blah blah blah, yeah? Okay, so that's the total area. Let me check everything. Yep. I'm just gonna plug everything in the calculator there. So it's let's do the first term, 0.5 times 2 pi minus, well, I'm just gonna do maybe, wait, 1.8471879. I would like to keep everything precise, so that's how I do it. Answer, and then clear, and then I do 0.5 times in bracket 2 pi minus answer, yeah, times 15 squared plus the other area, 0.5 times 15 times 17 times sine of the same angle, answer, yeah, there you go. Here we go. So that's just 621.71. So that's just, we need 3 significant figures. So that, oh, gotta be 2. In meters squared. Everything is in meters, right? Yeah. I don't think they would trick you with the units there. Okay. C. Find the perimeter of the helicopter landing pad. Somehow I was saying landing page, like an internet. We need to find the perimeter. So we got a major sector arc, yeah. And then this line, and then this line. So it's just this little BC, which is 2 meters. And then AC, we got to do another sine rule again. So AC divided by sine of that theta again, which is 1.847 blah, blah, blah. Yeah, that's just the major segment angle there. Okay, the AOC, that guy. Yeah. Oh, okay. And then equals AC, which one should we take? I'm just going to take OA, which is 15, divided by, what? Sine of 0.6, right? Yeah. So that's going to be AC, which is 15 times sine of 1. Just going to take that rounded value there. Oh, divided by, right? Yeah. Sine of 0.6. All right, so that's 25.559. All right, 25.559. Okay. And then, yeah, so we add them up, and then we do 25.559 plus 2 plus the major arc there, which is theta r. So that's just 2 pi minus the same angle there. And then times r, which is 15. Right? Just S equals theta r. And theta is 2 pi minus 1.847. Okay, for that major arc. So perimeter is that. We're going to use a calculator. So I'm just doing plus here. 2 plus 2 pi minus 1.847 times 15. 94.1 meters. Right? There you go. Okay, I think I'm happy with that. And let's do number 7. Alright, so figure 3 shows a sketch of part of the curve C1, given that C1 has an equation that where fx is a cubic function, touches x-axis and origin cuts x at x equals 4. Touches means that is where the turning point is. passes through the origin, passes through the point, 10, 120. So we need to get the cubic equation. Now we need to know first that y is equal to ax cubed plus bx squared plus cx plus d. That's just the general formula, general form of a cubic function. You need to know that first. Now, because we kind of also know that 0 is on the line. 0 is on the curve. So already we can put 0, 0 into the x and the y. So that will make d equals 0, right? So d goes away. Yeah. And then if we sub in 10 and 120, so we have 120 here being the y equals 10 cubed, so that's 1000a plus 100b plus 10c. We get that equation. Well, we can simplify a little bit, so we get 100a here plus 10b here plus c here. I'm going to keep that equation for now. And then what? We also have a turning point at the origin, don't forget. Oh, hang on. We also have the roots there being 4, right? So if we sub 4 in, we should get y equals 0, right? So here we have y equals 0 equals 4 cubed is 64, 4 squared is 16, 4 is just 4c, and d is already 0. So we get 2 equations now, and the last one should be about the, the turning point being at the origin, okay? Because that's the only turning point we know. So dy by dx equals 3ax squared plus 2bx plus c. I just differentiated that function. I'm going to put it to 0. Yeah? And I know that this happens at x equals 0. Makes sense? Because it's at the origin. Yeah? Touches the origin. So that means the first 2 terms goes to 0, and that leaves c also 0. Okay. Okay. So if that leaves c 0, then the first this first equation and the second equation, so the first equation becomes 120 equals 1000a plus 100b, because c goes away. And the second equation now becomes 12 equals 1000a. Wait, no, those are the same equations, sorry. And the second equation is here, sorry. So 0 equals 64a plus 16b, because c goes to 0. So what can we do with these? Well, we just solve, right? So we can do like, if I move 64 to the other side and cancel by 16, so I get minus 4a here equals b, right? Minus 4a equals b. I'm just checking, yeah. So we can put to the first equation, so we have 20 equals, I'm just going to add a page, 1000a plus 100, b is minus 4a. So 120 equals 1000a minus 400a is just 600a, right? And a is just 1 over 5, 120 divided by 600, yeah? Okay, so we got a, so b should be minus 4 times a, which is minus 4 over 5, right? That should be easy peasy, yeah? That should be easy peasy. And that's it, we got everything. So fx equals ax cubed plus bx squared, z is 0, and d is 0. And that is it. Yeah, that should be it. Yeah, that makes sense because we get x squared. So this is like x squared. You can look at it as this. And that confirms the turning point at 0 because x squared here is like a repeated root. Happens at 0. And then we got, if you equate this to 0, you get x equals 4, which is one of the roots there. All right. So there you go. Let me check with the 10 and 20. So if I put 10 here, this is 1000 over 5 plus, minus 4 over 3, 4 over 5. and that is also 100. So what is that? 200 minus 80, that's 120. Yeah, I'm happy with that. Just checking the equation if it works, yeah, because we have time here. All right. The curve C2 has equation y equals 1.2x times that. That is quadratic curve, an inverted quadratic. On the following page, there is a copy of, yeah, we need to plot, right? Okay, so we need to plot with that. So let me just get that graph first, if you don't mind. Okay, I'm just going to get that graph right here in my thing. And that is the graph. There you go. Here we go. There you go. So we need to plot this thing. Okay. So we're going to sketch the curve C. So because 4 is kind of like here, yeah? 4 is kind of like here. This is where it intersects at 8. Wait, hang on. Let me check something. I think I saw something, but anyway. Okay, 8. Yeah? Okay, and then the curve should also cut at 0 because we have 1.2x there. So it cuts 2 points. And the curve should be an inverted parabola, so it should look something like this. Yeah? So maybe the turning point is at 4. There. Just like that. Like that, yeah? Okay. Am I happy with that? Yeah, you know, that should be fine. It doesn't say if I should give all the coordinates of everything. That is it. Okay. Use algebra to find the part C. Use algebra to find the coordinates of the points where C1 and C2 intersect. Wow. Okay. How many points they intersect here? 1, 2, right? And maybe let's see if there's a third point there. So let's solve that. So we're gonna equate them, right? 1.2x, 8 minus x equals just the quadratic that we just, cubic equation we just found there, right? Let's see what we should do. Okay, I think we can cancel one of the x's first. So divide by x, knowing that x is equal to 0 already. So we have 1.2. So here I'm going to cancel that x. I'm going to cancel 1x from both terms here. Yeah. So it's 1.2 times 8 is 9.6. 1.2 times minus x is 1.2x, right? Yeah. Okay. And then one of the x cancel once. So we have x squared here and minus 4 over 5x. That becomes a quadratic. We multiply by 5, yeah? Multiply by 5, so that is 48 here. Minus 6x equals x squared minus 4x. So we have x squared plus 2x, moving everything to the right part. And then minus 48. The answer will, we can check the answers. See if it makes sense on the graph, right? 48, let's see, it's 8 and 2. 8 and minus 6. So x plus 8 and x minus 6 equals 0. Yeah, I prefer that method. And then we have x equals minus 8 and 6 and 0 that we got earlier. Because we know from that, right? So let's see if it makes sense. 8 is here, check. Wait, what? Minus 8, sorry. So minus 8 is far to the left. So yeah, they actually do intersect once again somewhere. Like that. Yeah. And then we have 0, and then we have 6 here. So this is about 6 actually. Yeah. So that all makes sense, I think. Coordinates of points where, okay, we need to find x and y. So y would be equal to, whoops, wrong color. If x is minus 8, what would be y? Which one should we use? I'm just going to use the quadratic one. So that's just 1.2 times minus 8, right? And then times 8 minus minus 8 is 16. So that is minus 768 over 5. Really? Yeah. Checking. That should be fine. Yeah. And then we change that to 6 instead. So my 1.2 times 6 and then times 8 minus 6. I'm using the curve 2 equation there. Yeah, I think I'm happy with that. So 72 over 5. And then 0, it's 0, 0. So 0 for the y as well. Okay. So we have the answer of all intersections would be minus 8 minus 768 over 5, 6, 72 over 5, and 0, 0. That would be my answers for part C here. Next, number 8. Here we go. 44 minutes. A curve has equation y equals fx. The point P for 12 lies on the curve. Given that blah blah blah, the equation of tangent to the curve at P has equation that, where C is a constant, I show that K equals, okay, K equals 1/4. So the equation of tangent there is telling you the gradient at P, right? So the dy by dx at P is 10, right? So if we equate, wait, hang on. Yeah, we already know the x coordinate of P. So if we plug that into, this, knowing that the x coordinate of P is 4, yeah, like that, we should get the K value, yeah, using that information there. Okay, so what is that? It's 10, 10 this is 6, right? So 10 minus 6 divided by 16 equals K. Yeah, so that's just that. So this is just 4 over 16, which is a quarter as required. So part II. Find the value of C. The value of C, let me sip water, is just the linear equation there, the y-intercept. But we know that P lies on the line because that point P is the point on the tangent. Okay, so if we substitute the coordinates of point P into the linear equation, we should get, it's just that. Yeah, just checking all my substitution. Need to be very careful. I hope I'm a good example for you guys. 12 minus 40, sometimes I do make mistake again. Yeah, just emphasizing that. Yeah, and that is minus 28, isn't it? I think I'm happy with that, so that's the answer there. And then part B, right? Hence find the value of f double dash x. That is just the second derivative. We just differentiate the first derivative again, okay, and substitute p into that. So f double dash x is just equal to, we are differentiating by respect to x of these two terms. K is just 1 over 4 there, we already know that. Okay, hang on. Yeah. Alright, so this is just equal to, differentiating x to the power of a half here is just bringing a half down, and that is just subtracted by 1. And then bringing 2 down, we have a half, and x to the power of 1 because that's 1 less. Okay, I'm fine. And so that's just 3 over 2, x to the power of a half. I should write it as maybe put x down here and x over 2 like that. Okay, that's f double dash x. And at P, so f double dash x at P, x coordinate of P is 4. So it's just going to be that. So 3 over 2 times 2, 3 over 4 plus 2, right? And then we do the fraction there is just 8 plus 3, which is 11 over 4, right? Yeah, so that's it. Okay, part C. Find fx. All right, just the function there. So now we need to integrate. So fx is just integral of f dash x. And you're just going to take that form. K is already a quarter there. Yeah, just that. And there is a constant, of course. So that's 3x to the power of 3 over 2 divided by 3 over 2 plus a quarter times x to the power of 3 divided by 3 plus c. Yeah? So far so good. So that's just 2 there. If you do the numbers there, this is plus 1 over 12 x to the 3 plus c. Okay. Now we know that point P lies on the curve. So that is the best shot that we can use to find the C value here. Okay. So we put 12 equals 2 times 4 to the power of 3 over 2 plus 1 over 12 x to the power, which is 4 to the power of 3 plus c. All right. So c is just moving everything on the other side. 12 minus, what was that? 2 times 4 to the power of 1.5, yeah, and also minus 1 over 12 times 4 to the power of 3. That's just 4 over 3 for C. Whoop, 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 I made a mistake. I just saw that this should be a minus. I have to be snappy on my mistakes here. Okay, 12 minus that, minus again, yeah, when you move for that. Ooh, okay. 28 over 3 minus. Just gonna check everything again. Yeah, should be fine. And then now we get the function. So fx is just 2x to the power of 3 over 2 plus 1 over 12 x to the power of 3 minus 28 over 3. Yep, that's it. Okay. Alrighty. Yeah, I'm just checking. Yeah, should be fine. Number 9. Number 9, we have complicated looking graphs here. Figure 4 shows a sketch of C1 and C2 with those two functions, okay? Describe fully the single transformation that would transform, part A, the graph with equation y equals root x onto C1. So if we put fx to root x, yeah, to get to root 2x, because C1 is root 2x, you need to do f2x, right? Yeah, which is gonna substitute x with 2x. So this is what? Compressing the x-axis, right? So I'm just gonna say part I here. What do we say? Compressing. Compress along the x-axis by a factor. Well, we can just say, no, not a scale factor. Yeah, compress along the x-axis by a factor of 1 over 2. Should I say that? Or if we say stretch, I mean, it doesn't make sense to say stretch. It's like it's half there. Yeah. I think that's fine. It's like shrinking down. Yeah. Okay. So part AI, the graph with equation y equals minus root x to C2. Okay. So basically that is just adding 12, right? Yeah. So as you can see, you go from y equals minus root x to 12 minus root x, that is just plusing 12. So this is just translating up by 12 units. Yeah, that's it. Okay. The graph C1 and C2 meet and the point P as at the point P as shown. Okay. B, I show that x coordinate of P is the solution of that. Okay, so we're just gonna equate the two function there. All right, here we go. Okay, let's see, what can we do? Okay, so we can use some Surds property here, just to look at that in another aspect. And then how about multiply everything by root 2 there? So we get 2 root x here plus 12 root 2, yeah? Minus, that doesn't make any difference, does it? Hang on. Okay, I can combine the root x term. Yeah, I need that line. Okay, I'm gonna need that line. Yeah, because then this is root 2 root x plus root x equals 12. So if I factor root x out, I get root x, and then in the brackets, root 2 plus 1 equals 12. Yeah, and if we want root x as a subject, we can just divide both sides by that. So I get this. And then we multiply by the conjugate, yeah, which is just the opposite sign there of the denominator. This is just rationalizing it. So we have what? I'm just going to multiply the top bit, which is 12 root 2 minus 12, and the bottom bit becomes 1, right? Just 2 minus 1 there. And there we go, we have it. So 12 factored out. Actually, I shouldn't have multiplied that in. Yeah, as required. And then I hence find the simplest form, the exact coordinates of P. So we need to square that, right? So x equals, square that. So 144, 2 plus 1 minus 2 root 2. Just squaring that, yeah? So in simplest form, there you go, I got you. There you go, right? So just simplify that. And then we need to find the y coordinate, so I'm just going to plug in, let's see, which one should we plug in? If x is that, then, oh, we got root x as this one. So yeah, so y is just 12 minus root x. I'm going to use this because we already know root x is that, right? Yep, so 12 minus 12 root 2 minus 1 there. So this is just 12 minus 12 root 2 plus 12, right? And that is just 24 minus 12 root 2. Or better yet, is just 12, 2 minus root 2. Yeah? All right, I think that's fine. So that's the y, that's the x. Exact coordinate of P would be, ooh, that's a horrible coordinate, right? Don't you think? Then comma 12, 2 minus root 2, like that. Yeah, that's the exact coordinates of P. Let me double check here. Seems a little shaky here, things. Yeah, we can check from the x there because the x should be the same because they got it already. So x squared is just 144, 2 plus 1, yeah, minus 2 root 2, yeah, 3 minus 2 root 2. So that should be fine for the x. And then I use the root x there and using the C2 function there. Sorry, yeah, the C2 function. 12 minus root x. So that is minus 12 root 2 plus 12. Yeah, I think I'm happy with that. Okay, so let's go on to the next one, which is the last one, I think. Number 10. A, find the exact solutions to the given equation for k equals 4.5. Okay, let's have a look. Okay, we just plugged 4.5 in, right? Shouldn't have thought too long there. So 4.5 subtract 1, we get 3.5 x to the 6 plus 4x to the 3 plus 0.5 there equals 0, right? Yeah. So how do we do this? Well, I mean, I would like to simplify this a little more. If I divide everything, well, actually, if I times everything by 2, I get 7/6 to the x to the 6 plus 4x cubed plus a 1. Wait, no, the middle term is 8. Again, guys, attention mechanism here, I need to be careful. Okay. Yep. Well, you can look at this as, you know, a quadratic of x cubed. Yeah? So I'm doing quadratic factorization here, but instead of just x, it's x cubed. Because when you do 7x cubed times x cubed, you get 7x to the 6. And then let's try 1 and 1, and that should work, right? Because when you shake the middle term, this is 1x cubed, this is 7x cubed, you add them up, you get this. And the 1 and the 1 multiply to 1, that's easy. So that is just 7x cubed plus 1 equals 0, or x cubed plus 1 equals 0. So this is exact solutions. Okay, so we need two answers. So this is just x equals the cube root of 1 over 7 minus, yeah, as well. Just going to make that clear. Okay, and that's possible because it's not a square root, it's a cube root, so it can be, wait, what? It should be a negative inside. Nah, that's the same thing. That's the same thing. Yeah, that's the same thing. I mean, if you, yeah, same thing. Okay, or x equals minus 1. This one is just minus 1. So cube root of minus 1 is just 1. Cube root of minus 1 over 7 is just that. Okay, so this is the answer. Part B. Find the set of possible values of k for which the given equation has no real roots. Okay. All right. So we're going to still take... All right. Okay. Okay, this one, yeah. Right, guys. Okay. So I think we can use the discriminant, right? Yeah. So, okay, this time I need to let, say, y be x to the 3. So we would have k minus 1 y squared, just to be safe here, plus 4y plus k minus 4 equals 0. And then we do the discriminant. So b squared is 16 minus 4 times a times c. And you can see that it's kind of similar to if I didn't do letting y be x cubed, right? And that should be what you end up with anyway. And then we have has no real root, so that has got to be less than 0. Okay, expanding that, we get minus 4. I'm just going to expand inside first, so k squared minus 1 and minus 4, we get minus 5k, and then plus 4 in here. Yeah. Okay. All right. Okie dokie then. So I'm just going to do 4k, hang on, there's no equal sign here. 4k squared minus, it's just k squared minus 5k plus 4 greater than 16 over 4. So if you rearrange that, you should get that. So I just move this whole thing to this side first. I get a 4 and then brackets here, and then I do 4 divide on the other side, which is 16. So this is k squared minus 5k, and after you get 4 here, you subtract, then you are left with 0 there for the constant term. So that is just k times k minus 5 greater than 0. Okay. So yeah, it's just 0 and 5, right? And then oh no, this is greater than sign, so it's k greater than the larger one, or k smaller than the smaller one. Yeah, that's probably it. So let's see, 4.5 is not in our range, right? Because 4.5 has 2 real solutions. It should be greater than 5 or less than 0, but 4.5 is not in the range. So that makes sense. That kind of helped verify that we are kind of okay here, yeah, at least for one anecdotal evidence there. Here, yeah, set of possible values, okay. Yeah, I think I'm gonna go with that, yeah, because we have a cubic here. So when there's no solution to y, for these values of k, there are no real solutions to y, hence no solutions to x cubed, right? And hence no solution to x, yeah. Okay, yeah, I think it just feels a bit off here. Okay, let me check if there's any more question. All right, no. Okay, I'm gonna spend more time thinking on this one because it feels a bit off just to say that with 4 marks there. I mean, I could be right here, but I'm just being careful here. If there's anything else I can do there to make it more secure. All right, I still have time. Yes, just an hour here. That's probably it, though. So there's no solution to y. That's probably no solution to x cubed, and no solution to x. And that is the range. Yeah, I'm gonna go with that. So that's just my thorough walkthrough there, I hope. Alright guys, I have marked the paper and I lost 2 marks from silliness again. Yeah, can never be perfect. Because I didn't read the question that the question wanted the unit in degrees, right? So it was that question where I should have put the answers in degrees, not in radians, right? But okay, I think you've seen in the video already because I annotate the video. Now let's go through each question individually, yeah, like feedback. So number 1 here. Yeah, number 1 is typical. It's nothing out of ordinary here. It's just laws of indices. But you got to be careful when you use the laws of indices. They are not too bad. I've seen worse. Yeah, I've seen worse than this. This is okay. Yeah, so I'm not gonna dwell into much into this. This one, yeah, just differentiate the function and then use it to find use it to do part B, right? So in part B, you have to use the derivative to find the gradient and then equate that to the one at point C, the one at point P, right? So this is okay. You just have to solve the exponential equation at the end, right? So that's fine, I think. Number 3, yeah, split the terms. I mean, like, because you don't know how to do any integration techniques yet, because this is P1, so the simplest way to do this is to expand the top and split the fractions into partial fractions and then integrate separately like I do here. Would be the simplest way, and that's fine. Nothing particularly too hard here. This one, yeah, this one I lost marks. Yeah, already told you that. Should have been the values in degrees. Yeah, so if I convert that to degrees, would have been right, but this is wrong. So I deducted 2 marks because I lost one in A. Of course, that's just 1 mark. But in B, I think I got 1 for the -4. Yeah, so that was right. That's fine. Now, for part C, I would say this is recently in P1 papers, they typically do this. So they ask you the number of solutions, giving you like 2 functions, yeah, and so on. So make sure you understand that. If you haven't, understand how I came up with all the 3 answers in part C. Yeah. So basically, you need to look at the block, like the repeating unit of the 2 graphs, yeah, and then use some multiple, like multiply the block to get the number of solutions. So for example, the first one here, because in 360 degrees, there are 2 solutions. So that's how I did it. So I did 18,000 divided by 360, so to find the number of blocks, and then I multiply that by 2. And you gotta also be careful, because sometimes you might think the left and the right are the same. Maybe they're not, depending on the graph, right? Because in this case, the cosine function is like symmetrical. Symmetrical as in the left side and the right side of the y-axis are the same. But for the sine function, they're not the same, right? So you got to really be careful, because look at the range. Don't go too fast on this. Be thorough. Maybe you want to be slow on this kind of question. Be thorough and work through it. Yeah, and I think I showed you how already. Yeah. All right, so this is the one I would stress. Yeah, because people lose marks on this one usually. Okay. Number 5, yeah, number 5 is coordinate geometry about linear equations. So this should be fine. This is typical. Make sure you know how to do part C, I think. Yeah, part C might be subtle. It's not that clear how to do, because you want to find the shortest distance. If you don't visualize this in the graphs, you might not see it clearly. And that's what I did. I visualized it. So I saw that, okay, the shortest distance is just that perpendicular distance. And we can do something about it, right? So the way I did that was just do a, like find the Pythagoras, because I know where P is, right? So I could do that, and that was right, yeah? So usually if it involves graphs and plots, try visualize it out, and you should be okay. Yeah, you should be okay. You should get some idea. All right. Yeah, this one is fine. Radian measure, yeah. Well, gotta be careful about finding the area and the perimeter here. So make sure you don't miss anything out. This is where you want to be thorough as well and read the question carefully. Sometimes you might think they give you this number, but maybe not. This question is easy to make silly mistakes, yeah. So try to be thorough for this one as well. Number 7. Well, number 7, yeah, is a cubic plot here. And yeah, I think this one is also fine. Well, the first one might take a little time. You gotta gather all the information and find fx, right? So everything must be determined, like the constants, the a, b, c, yeah, all the constants in every term. And yeah, might take a while. So you see, sometimes you think, okay, this is just 3 marks. Why do I have to do a lot? Well, I mean, yeah, that's the thing, right? It's never perfect. It's subjective, I would say, sometimes. Because sometimes 1 mark is a very hard question. 1 marker can be very hard. So sometimes the amount of marks does not reflect like the amount of work. Or sometimes the amount of marks does not reflect the amount of thinking. Sometimes 1 marker questions can make you think a lot. Well, actually what you write is just 1 line or 1 sentence. But sometimes 1 mark, you might have to do a lot to get the 1 mark without thinking too much, maybe. So it's either thinking quite much, writing a little, or thinking a little but writing much. In this case, I think it's the latter. So, I mean, it's obvious. You gather all the information and get the line, so you don't need to think a lot, just like solve the algebra and everything. When I say thinking a lot, it requires a little more creativity. It's not just like tedious work, right? Yeah. And creative thinking might be a question like this one here, you know, where you need to visualize and think the best way to find what it wants, right? Yeah. So, you know, it's a bit subjective here. So for part B and part C, yeah, part B is just drawing. So you got C2, so it's just testing you if you know how to plot a quadratic function in a graph, yeah. Part C is just solving it, right? So you got to be careful on that one, yeah, because there are 3 intersections, I think, and then I got 3 points here. Question 8, yeah, still calculus here. Question 8, so it's just differentiation and integration, so make sure you go through thoroughly. They give you the derivative function there, yeah, and then you need to use the information to find things. So this is basically just going through. So the key strategy here, particularly when you do a UK paper, usually all the information they give you will be useful. So if you think you are missing some information, like if you haven't used a particular piece of information, then it means you are missing something, maybe, right? So let's say somehow you haven't used the fact that the equation of the tangent, blah, 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 this thing, then you're missing something. That's the cue there, right, that you should take, yeah, when doing a question, yeah. And at the end you find fx, yeah, that should be fine if you do all of those. Number 9, yeah, it's a bit tricky, I would say, about the plot. So you want to be thorough about the transformation here and which one, going from which one to which one. This is from this equation to curve C. So curve C1 is already plotted, C2 is already plotted. So I think I walked through that, explained that thoroughly. So you go from fx, which is root x there for part AI, and then f2x is just substituting x as 2x instead, and then that should you know, because you multiply 2 to the x when you substitute, so that's gonna multiply the x coordinate by 1/2. So it's compressing, shrinking down, right? So that's the transformation there. And then, yeah, part B is fine, just find the answers. So you need to do in terms of exact. For those of you who are not that proficient at Surds, this will be where it tests you, yeah, about Surds and everything. So you got to be careful on Surds here. If you use a calculator, it's going to give you a decimal number, not exact, right? So you want to have some skills about Surds here, yeah, okay. And number 10, yeah, number 10 is a good one, I think. Number 10 tests some, you know, out-of-the-box thinking. It's not that out of the box, but how do you find the answer to the equation that is not typical? This is not something you have solved usually, is x to the 6, but do you see that you can tweak a little? So you can substitute, as I do in part B here, substitute y being x to the 3, and then you change the form. So if there's no solution to y squared or y, then there's no solution to x cubed. So that will make it no real roots then, and it will be brought back to quadratic. So if you have seen equations that are not solvable, yeah, maybe the key strategy is to maybe try and make it quadratic, right? Somehow try and make it quadratic. If you can't make the thing you want to solve, let's say y, if you can't make y the subject straight, then it's probably quadratic or a little worse, cubic, but probably not anything else worse than that. And this is quadratic, right? If you tweak the form a bit, yeah, use some substitution. Because quadratic is solvable, right? We have formula here. And that's it. So that's the condition. So, and that was it. I hope if you have watched this far, you find the video useful. So why not give me a subscribe? And I have walked through many other IAL math papers, so do check out the playlist. And I hope to see you in the next one. Bye.